So here's another problem. Express 4.6 sine omega t minus 7.3 cos omega t in the form r sine omega t plus alpha. We've got to be careful this time. If we think about it, we've got our A and B in our right angled triangle. I've just copied that triangle we had earlier over on here so you can see it. But this time we have a situation where A is positive, so A is positive, and this is taken to be the positive axis, isn't it? So A is along here, so 4.6, but B is negative, so B means we're going down here, 7.3, which means when we draw our right angled triangle, we're going to end up with something like this. And so if I'm now putting my R in, R is going to be down here. So the signs make a big difference as to where my right angled triangle effectively is. So now I can put on what A and B are, 4.6 and 7.3. This is my phi. And now I can work out the problem. I can work out R and phi. Is this going to have a consequence on phi? The fact that the angle's here, what difference is that going to make to it when I work out what phi is and put it back in again? Yes, it's negative. Good. Convention takes positive angles as going around this way, doesn't it? So this is positive, as it was in the earlier problem. But this now is negative. So when I've calculated phi, that's going to be a negative value. So now we can carry on, use the formula we had before to find R, square root of A squared plus B squared, same, phi, 10 to the minus 1, B over A. I don't really need to worry about the signs when I'm working out phi and R. I just need to take them into account when I put them into the final solution. So calculate R and phi, and then end up with that wave function with values of R and phi inside it. So when we put these values in to here, just put the value, the 7.3 in. If you've got to be careful, if you put minus 7.3 into the calculator, one thing, if you remember, if you put into the calculator minus 7.3 and then hit the square button, what do you get? No. Yeah, but if you get minus 7.3 squared in, if I do that on the calculator, what does it do? Yeah, but is it? What does the calculator give? You get a minus, don't you? Because the calculator, for some reason, squares a 7.3 and then makes it negative. If I want to do it properly, so you could do it on the calculator, Jack, if you put a bracket round the minus 7.3, then it would work. It's one of those quirks of the calculator. You have to be careful of that. But the best way around it is just to ignore the negative sign. Yeah. So what do you get for R?
8.63.
8.63, and for phi?
Minus 1.0085.
0.085. So we could round those, couldn't we? About 8.6 to two significant figures, and 1 to one significant figure. Well, actually, to two significant figures. So now we can put those back in. What we can say is that our original wave, 4.6 sine omega t, minus 7.3 cos omega t, equals R, which is 8.6 sine omega t, same angular velocity, minus 1, if we're working in radians. And again, we can go towards the graph to check this. We can type in y equals 4.6, was it? Minus 7.3. 4.6 rather, minus 7.3 cos omega x. And I get that. So let's zoom out on it again. So you can see it. There's our wave function. But what we're saying is that that equals y equals r, which was 8.6, thank you, sine brackets omega x minus 1, close brackets. Okay. And again, we find these wave functions map directly on top of each other. So we can rewrite, we can say that this wave function here, this wave function, these two waves combined together with the same angular velocity can be replaced with a sine wave with that amplitude and that phase angle.